Welcome to WEFTEC Now. I'm the host, Travis Loop. I'm here with Dan Dair, Vice President of Innovation for World Water Works. How are you doing, Dan?
I'm doing well.
Excellent. Could you tell me a little bit about your company?
Sure. So World Water Works is a company. We're based in Oklahoma City. We've been in business now for around 21 years, so it's been a long time. We have offices U.S., but we also have offices overseas in the Middle East and India. And we really are focused on bringing process solutions to our wastewater clients in the wastewater market.
Sure. So you've been in this market for a while. What are some of the trends that you're seeing when it comes to wastewater treatment?
Sure. What we're seeing a lot of is that there's a renewed focus on resiliency, water reuse. We're also seeing energy coming into play. Energy is something that in the past, everyone's always considered energy in the United States to be cheap, but now it's becoming more of a concern. We're also looking at some more, additional renewed interest in biosolids, and World Water Works is kind of, we're trying to figure out where our customers are going, what they need, and so by following these trends, we feel we're getting a pretty good understanding of where that's going to go.
Well, that's very interesting. That's really all about resource recovery, right?
Correct.
Recovering that changing from just straight wastewater treatment and sending that water away to actually getting those resources out of it, reusing water, capturing nutrients, generating energy. That's the transformation happening.
And WEF has gone ahead and kind of rebranded the wastewater treatment plant to the Water Resource Recovery Facility for that exact reason. Yeah. And a lot of times, there's a lot of inherent energy or indigenous energy that's present in wastewater through heat recovery, through the carbon, redirecting carbon to anaerobic digestion. And so a lot of that is really what's being focused on, and it's more of like the idea of intensification, right? So it's been there, but now it's looking to do it better with the existing infrastructure, and really not trying to add a whole lot more to the existing infrastructure or expending a lot of capital to do that.
So that sounds challenging or like an interesting process. Yeah. Intensification, could you talk about that a little bit more?
Yeah, so intensification, I view it personally as just getting more from less, right? So taking an existing facility, seeing what you have available, and then optimizing the process to then meet either lower limits for their effluent discharge, meet energy needs within the facility itself. A lot of facilities are focusing on becoming energy neutral, and some are even looking past that and saying, I want to produce energy. And if you look at a lot of these wastewater treatment plants, they are the largest consumer of electricity in their communities. And a lot of that comes from aeration. And aeration blowers they're on 24 hours a day, 365, and they're blowing air into these basins. And the idea is that if they can figure out ways to reduce that energy input, it becomes easier at that point to then become energy neutral.
So utilities are really pushing for these type of solutions. It's really a growing trend.
Yep. Yeah. And there's lots of trends on the market, and World Water Works, we're really focused on aeration is one of the trends we're looking at. We're also looking at densification, which is a process of improving the existing activated sludge technology, and we're also looking at side stream treatment. We were the first company to bring Animox side stream treatment to the United States.
Okay.
We delivered a small project to HRSD in Virginia, which
Hampton Roads Sanitation District.
Correct.
Yep.
Very innovative group, and so we were very happy to be able to team with them and deliver that product.
So let's dig even further into intensification. A utility, a facility wants to do this, to get more from less. What are some of the approaches and solutions that you can put in place to do that?
So one of the real exciting technologies that we have now in this market is a technology called indents. And indents is really just a very simple idea. It's selective sludge wasting. So we're trying to waste bacteria that are considered bad and keep the ones that are considered good. And through this process, we're seeing enhanced biological phosphorus removal, we're seeing improved throughput, we're seeing lower chemical usages at these facilities. And really the idea is that if you have a denser sludge or sludge that settles better, you could potentially improve the treatment capacity of that facility. Because all treatment ends with some sort of settling or flotation or what have you. And before they discharge the environment, that sludge has to be settled, or that bacteria population has to be settled, and the clear supernatant then goes off to further processing or to the environment.
Okay, that sounds good. And anything else? Any other approaches and solutions?
Yeah, so the other one that we've really been coupling with indents is this idea of aeration control, advanced aeration control. And The technology that we're working with, it was developed through a partnership with a couple of utilities. It's called AVN, which is a AOBs versus NOBs, or ammonia versus nitrate. And the idea is that we're trying to take a facility that in the past they just added a lot of oxygen, right? It was residual DOs in that 1 to 2 to 3 milligram per liter range. And the idea is that that was the concept, that was what everyone thought needed to happen in order to maintain high nitrification rates. And what we found is that at lower DOs, we could still maintain that nitrifying population, we can still maintain the high enough rates, and not waste as much energy. Being
efficient, really.
Being more efficient,
right?
Exactly. And AVN is really just the balancing of nitrification with denitrification. So a system inherently has carbon coming in, and we're trying to then make sure that we're nitrifying enough that we can denitrify, but also being able to take that carbon, we talked about being an energy, and redirecting it to other processes, like to anaerobic digestion, to potentially phosphorus removal, things like that. So it's doing more with less, right? We're trying to get nitrification, biological phosphorus removal, and energy production out of the same carbon that's coming into the plant, regardless of what's happening.
Yeah. One thing that I want to talk about was settling issues. And could you talk about that a little bit?
Yeah, so again, a lot of facilities are activated sludge. That's the predominant technology in the industry. It's got lots of different makes, different types of activated sludge that different people offer, in the sense of just how it is applied. But it all in the end requires settleability. All right, so the sludge needs to have some ability to be separated from the liquid. When wastewater comes in, there's particulate separation up front in most of these treatment facilities, but there's also this soluble constituent that needs to then be removed, the soluble pollutants. Could be carbon, could be ammonia, phosphorus, and they need to be removed. And through this process, sludge is generated. And so as you're building up this population of bacteria, beneficial bacteria that are doing the work for you.
Good bugs.
Good bugs, exactly. The idea is that at the end, you have to then settle it. And if you can't settle it very well, or if you have, say, an influent that's allowing you to maybe get some additional foaming, filamentous type bulking, that it will affect your effluent quality. And facilities battle this on a regular basis. I mean, there's facilities that have just generally bad settling sludge, and then there's facilities that have seasonally, settleability issues that happen in the winter or the summer, depending on the facility.
The temperature change impacts that.
Cool. Yep. Yeah. And then also just and what's coming into the sewer system at that point, or the collection system. So with indents, we're really trying to make everything nice and steady, right? We're trying to make it so there isn't that fluctuation anymore, that they're seeing consistent SVIs, seeing lower SVIs, and with lower SVIs allows you then to push through potentially more wastewater through that facility without actually doing much to the infrastructure itself.
Yeah. A question about intensification in general and this whole transformation to resource recovery. Have you seen that this is something that only kind of the large utilities that have a lot of resources themselves can do, and it's tougher for small and medium utilities, or what do you think that landscape looks like?
I think some of the larger facilities do have more resources available to them. They have a lot of folks there. They also have a larger base to then pull in resources. But a lot of these things can be done at all levels. Indents is a technology that can be applied to the smallest treatment plant, and they could see the benefits from that. Same thing with AVN. It's a technology that you could easily implement through it's PLC code basically. You look at the instrumentation. Instrumentation and controls have come down in price. The quality's gone up. The reliability's gone up. So a lot of these smaller utilities that maybe didn't have the resources that were available to these larger facilities, they're now seeing the opportunity to go out and buy these probes and being able to get that additional data that allows them to help operate that facility.
Maybe wanted to talk about municipal versus industrial. Are there differences here in what you're seeing on the two sides of the house, if you will?
Yeah, so we are active in both markets. We have a large industrial group and we have a large municipal group. And in the industrial group in the U.S., for example, we deal with a lot of food and beverage clients. We deal with a lot of just the heavy industry, steel, and steel is something that we're pretty proud of. We've actually found some opportunities to use some of our technologies to help them create a better product, increase throughput, and kind of get rid of some of this old antiquated equipment that was troublesome to operate, a lot of maintenance required. So to me, that's intensification, right? They're able to do more with their existing facility by having a better quality of water coming in. And this water is processed water, it's not wastewater. This is water that they're recycling. So the idea is that they're recycling water at a higher rate, and they're able to use it for a longer period of time and not have to then pull from the natural environment.
So this is good for them from a business standpoint, and it's good for the environment, like you said, at the same time.
Exactly.
So real
And then,
win-win.
and then also on the industrial side, there's the oil and gas industry. And the oil and gas industry, I mean, everyone hears it all about in the news. And there's new areas that they're exploring for oil, and a lot of these areas don't have water. It's not a readily available resource to them. So by finding these oil deposits and then looking to capture this oil, they need to use water in the process. And by being more effective with that water, having it be able to be reused multiple times is something that we're looking at and trying to maybe help them develop a better quality of wastewater for that return process.
And the quality of, if they improve the quality of the wastewater or the produced water, I guess they can use it again.
Again and again, yep.
And then, so then that helps them from a business standpoint and the environment again, because you don't have to discharge that water somewhere.
Yep. Yeah. I mean, it's actually a very simple thing, but again, it's a need that's out there that we're pretty happy that we found these guys.
So it sounds like industry has some of the same thinking of the municipal side of recovering resources and being more efficient.
Yeah, and I think there's different drivers on each side,
Sure.
right? But the industrial folks, I mean, they really are looking to, create a better product and then do it at a lower cost, right? Municipal side is a little bit different because they're being told that they need to reach these effluent quality limits, but you only have this much money to do it, or you have this infrastructure that you need to use in order to get there. And so that's why this intensification, or this idea of like stretching what infrastructure you have to cover what these new regulations are coming down, or the idea of conserving electricity, or the idea of getting more throughput to that system is important.
Sure. I wanted to talk a little bit about where you all work in the world, because you mentioned that you're based in Oklahoma City, but you have some international offices, and I just wonder if you could mention those. Especially you talked about you all have set up shop in India fairly recently, and that's a different type of work.
Yeah. So our main office, where World Water Works was founded, was in Oklahoma City. Probably 3/4 of the folks that work for World Water Works are based in Oklahoma City. And then there's a group of people that are kind of spread out around the United States. For our international group, we call it World Water Works Asia. They have offices in Dubai, in the Middle East. They have offices in India, in Hyderabad, and Mumbai. And really they're seeing very similar market to what we're seeing in the United States, but it's just at a much grander scale, right? So a lot of places don't have basic wastewater. India, for example, there's a lot of projects out there that are looking for opportunities. And what's nice is that these folks are taking advantage of the innovation that's occurring in wastewater in the US and in Europe, and they're
Coming in at a higher level of
So
treatment or more advanced process, more innovative.
Yeah.
That's very interesting because they're starting from ground zero.
Correct.
Really.
A lot of times they're starting from ground zero.
Wow. So they can put some of this in rather than having to retrofit or take out some old stuff and put in new.
And so in the United States, it's a lot of brownfield, which is taking an existing plant and retrofitting it. Over there, it's a lot of greenfield. So they're building fresh. So they have a lot of ability to be very flexible and kind of come up with this wastewater treatment idea of, I need to do something today, but I also need to be prepared for my future.
Well, Dan, thank you so much for your time. I learned a lot, and
thank you.
I appreciate it.
All right. Thanks, Travis.
Thanks for watching. For more interviews, please check out weftec.org/now.